Hello everyone. Okay, so in this video we're going to be looking at how we can complete the square or find the complete square form of a quadratic equation or expression. So completing the square is just another way we can rewrite a quadratic. We're just going to do some manipulating and rewrite it in another way. And this complete square form. This can tell us other things about this graph, like its maximum or minimum point. It can help us easily find solutions. It could help us quickly determine the nature of roots, etc., etc. So, complete the square form. We're going to transform a regular quadratic equation, so like something like 3x squared plus 4x plus 1. We're going to transform it into a form that looks like this. So we're going to have a times x minus something all to be squared plus q. So it's called the completed square form because I have my x term or my x variable as a perfect square. So I'm manipulating it so I get a perfect square with x of x. Do all that, add my bits, Bob's your uncle. Right. So a is known as the leading coefficient of this quadratic. So the leading coefficient here is going to tell us the direction of the graph. It's going to be pointing upwards or it's going to be pointing downwards, etc. And then PQ is the turning point. So the turning point is just like base for a quadratic is just the maximum or minimum point. So this one's known as a maximum or like the biggest point, and this is known as the minimum, the smallest point. So completing steps in completing the square. So I'm going to do some now and do this example down here. So step 1, factor out the coefficient of x squared if it's not 1. So let's look at my example 1 here. X squared plus 7x minus 9. Well, my coefficient of x squared is 1, so I don't need to factor it out, so I can go on to step 2. Step 2, divide the coefficient of x by 2 and square it. Then that's step 3. So the coefficient of x here is 7, so divide it by 2 and then square it. I'm going to get 49 all over 4. Gorge. So step 1, step 2, step 3. Step 4, add and subtract this to our expression. So x squared plus 7x minus 9 plus 49 over 4 minus 49 over 4. So why am I allowed to do this? I'm allowed to do this because plus 49 over 4 minus 49 over 4, they cancel out this. That's essentially adding 0 to this expression. So that's why I'm allowed to do this. Right? Then what we're going to do is step 5, isolate the perfect square. So I'm going to bring this plus 49 over 4. And I'm going to bring it over to this x squared and the 7x here. So x squared plus 7x plus 49 over 4 minus 9 minus 49 over 4. This here can be written as a perfect squared. So usually this something squared we have here, that's what I'm going to put in my bracket. It's going to be x plus 7 over 2 all to be squared. So this is all equal to this. And then I simplify this, minus 9 minus 49 over 4. That is going to give me minus 84 over 4, I believe. Let me just double check my answers. $85, sorry. Minus 85 over 4. And that is my completed the square form there. So let's look at this one here. So step 1, factor out the coefficient of x squared. Boom, I'm going to have with x squared minus 2 over 5x minus a over 5. Next step, so step 2 and 3, half the coefficient of x and square it. So minus 2 over 5 divided by 2, all to be squared. That is going to give me minus 1/5, all to be squared, which is going to give me 1/25. Step 4, add and subtract that to my expression in the bracket here. So I'm going to have 5 times x squared minus 2 over 5x minus 8 over 5 plus 1 over 25 minus 1 over 25. Next step, isolate the perfect square. So I'm going to bring this positive 1/25 over to my x squared and x term. So I have 5 times x squared minus 2 over 5x plus 1 over 25 minus 8 over 5 minus 1 over 25. So this is a perfect square. This can be written as x minus 1/5 all to be squared. And then minus 8 over 5 minus 1/25 is going to be equal to 8 times 5, 40, minus 41 over 25. Then finally, step 6, multiply in this 5 here. So I'm going to have 5 times x minus 1 over 5 all to be squared. 5 times minus 41 over 25 is just minus 41 over 5 normal. And that is our completed the square form right there. We have completed the square. Right, so let's look at some questions here. So George rewrites the expression x squared plus px plus q by completing the square. He correctly obtains x minus 5 all to the square plus 31. Work out the values of p and q. So actually, this is more algebraic identities. So x minus 5 all to be squared plus 31 equals x squared plus px plus q. If I expand this out, I'm going to have x squared minus 10x plus 25 plus 31 equals x squared plus px plus q. X squared minus 10x plus 56 equals x squared plus px plus q. So equate coefficients. Minus 10 is minus 10x is equal to px. Therefore, p is equal to minus 10. Plus 56 is going to be equal to plus q. So therefore, q is equal to 56. That's that question. Donezo. Right, next one. Express 3x squared plus 18x minus 1 in the form a bracket x minus p all to be squared plus q. So we're completing the square again. Step 1, factor out the coefficient of x squared. So I'm factoring out a 3. I'm left with x squared plus 6x minus a third. Next step, half the coefficient of x and square it. So 6 over 2 all to be squared is equal to 3 squared, which is 9. And then I am adding and subtracting that into my expression in the middle here. So x squared plus 6x minus 1/3 plus 9 minus 9. Rewrite it now so I can isolate the perfect square. So I'm left with 3 times x squared plus 6x. Remember, I'm going to get this positive 9. I add it in here, bring it over, plus 9 minus 1/3 minus 9. Isolate the perfect square. So that's step 4. Right, isolate the perfect square. I'm left with 3 times x plus 3 all to be squared. And then minus 1/3 minus 9 is going to give me minus 28 over 3. And then finally, last step, multiply out this 3 here. So let me just fix this here, sorry for a second. 3 times the x plus 3 all to be squared is just 3 x plus 3 all to be squared. 3 times minus 28 over 3 is just minus 28. And there's my completed the square form there. Done. Right. So now we know how to complete the square. How do we interpret it? Or how do we interpret the complete the square form? So for quadratic in a complete the square form, a times x minus p all to be squared plus q, the turning point of the graph is the point PQ. So PQ is my turning point. So this is the point in the graph where it will be positive or negative. So if A is greater than 0, i.e. my leading coefficient is positive, so greater than 0 is positive, the turning point will be a minimum on the graph. So remember, with a quadratic, A positive quadratic looks like a U. So therefore, it will have a minimum point here. If it's less than 0, it will be a maximum point. Because remember, a negative quadratic has an N shape. So therefore, the apex will be on top. So it will be a maximum point. We can also use the complete square form to quickly find the roots of a quadratic equation and or comment on the nature. And the complete square form also helps us find values for x for which the graph is positive or negative. So before we do that, let's form a quadratic equation, complete the square form from the graph. So use the graph, write the equation of the polynomial in the form y equals a times x minus p all to be squared plus q. So I have 2 points on this graph. This point here is my positive point, 3, 4. So I know y equals a times x minus, so p q. So q is equal to p is equal to 3. So it'll be x minus 3 all to be squared plus 4. Now I need to figure out this a, but I have one more point here, this 2, 2. So I know x is equal to 2 when y is equal to 2. So let's sub it in. 2 is equal to a times, when x is 2, 2 minus 3 all to be squared plus 4. 2 is equal to a times minus 1 all to be squared plus 4. 2 is going to be equal to a times minus 1 squared is just 1. A plus 4. A is going to equal to minus 2. Therefore, y is going to be equal to minus 2 times x minus 3 all to be squared plus 4. That is my complete the square form I formed from a graph. So let's do an example here. This is an exam style question. So a quadratic equation has a minimum point 3 minus 11 and pass through the point 0, 7. Find the equation of the polynomial in the form a times x minus p squared plus q. So has a minimum point q. So just draw out a sketch. Always draw out a sketch. So it's a minimum point. I'm going to have a U-shaped graph. This is going to be the point 3 minus 11. And this point up here is another point on the graph where it's going to say it's 0, 7. Right. So y equals a times x minus p all to be squared plus q. So it's really important you know the general form of a quadratic of a complete square off by heart. So pq is my min or max point. So p is going to equal to 3, q is going to equal to minus 11. So I have y is equal to a times x minus 3 to be squared plus q, which is going to be minus 11. So now again, I have the same problem. I have an a here. I want to get rid of it. Well, I know x equals 0 when y equals 7. So using this, let's solve for a. So 7 equals a times 0 minus 3 all to be squared minus 11. 7 equals a times minus 3 squared minus 11. 7 equals 9a minus 11. 18 is equal to 9a. A is going to equal to 2. So therefore, to complete the square form is y is equal to 2 times x minus 3 all to be squared minus 11. And that's the complete square form there. And this makes sense because it's a minimum, so a has to be greater than 0, which checks out for us. Right, so let's look at some questions now that involve us interpreting a complete square form. So write 2x squared. Write 2x squared plus 12x plus 10 in the complete square form, and then state the turning point in the graph and whether it's a minimum or maximum, comment on the nature of the roots, and find the range of values for which the quadratic is positive. So, step 1, let's get in complete the square form. Step 1, factorize out the coefficient of x squared. So factoring out of 2, I'm left with x squared plus 6x plus 5. Then half the coefficient of x and square it. So 6 over 2 squared is going to give me 3 squared, which is equal to 9. So y is equal to 2 times x squared plus 6x plus 5. Add 9 and then subtract 9. isolate the perfect square. So 2 times x squared plus 6x. So remember, I'm going to get this positive 9 here. And I'm going to have a plus 5 minus 9. This here is a perfect square. And that can be written as x plus 3 all to be squared. And then 5 minus 9 is minus 4. Then finally, multiplying this 2, I'm left with 2x plus 3 all to be squared minus 8. And that is my final solution there. So, it's asking us to state the turning points. So, remember, a times x minus p all to be squared plus q. So PQ is my turning point. So let's solve for P and Q. So minus P is equal to 3. Therefore, P is equal to minus 3. And then finally, Q is equal to minus 8. So therefore, my turning point is minus 3, 8. And it is going to be a maximum. I say a maximum, sorry, a minimum point. As a is greater than 0. So remember, a here is the 2. So a and 2, so a is equal to 2. Since a is greater than 0, it is a minimum point. Right. So, comment on the nature of the roots of the quadratic. So, to comment on the nature of roots, we could just solve the completed form. So, let's just solve it. So, 2 times x plus 3 all to be squared minus 8 equals 0. I'm going to have here x plus 2 times x plus 3 all to be squared is equal to 8. Divides both sides by 2. I'm left with x plus 3 squared equals 4. Square root both sides. Remember, since I'm finding the square root of a variable, that means I have to let this be a plus or minus. So it's going to be x plus 3 equals plus or minus root 4, which is just 2. So x is going to equal to minus 3 plus or minus 2. So my solutions are x equals minus 3 minus 2, which is minus 5. Or x equals minus 3 plus 2, x equals minus 1. So, x equals minus 5, x equals minus 1. They are real and distinct roots. Right, which is how the roots are real and distinct. And the final last point here, since the graph has a positive leading coefficient, it will be U-shaped. So what we're asking for here, find the range of values for x for which the quadratic is positive. So it is a positive quadratic, so it looks like this. So it's going to look like something like this. We're looking for the values for which the graph is positive. So we're looking for these values and these values. So we're going to go over more of these in inequalities. Right, but what are my two roots here? Minus 1 and 5. So let me be a bit more accurate and redraw my graph. Alright, so we're going to do more of these in inequalities. But if I was to sketch out this graph, yeah? So it's a U shape because it is positive. So it crosses through the points minus 5 and minus 1. So I'm looking for the range of values for which the quadratic is positive. So I'm looking for these values and these values here. So when x is less than minus 5 and when x is greater than minus 1, the quadratic is positive. Right, so let's do one example here. This is from the 2017 paper. So write the function f of x equals 2x squared minus 7x minus 10, where x is an element of real numbers in the form a times x plus h squared plus k. So don't let you be fooled. This is just my perfect square form, but they're just being messy and rewriting it. So So complete the square form. So step 1, factor out of 2. I'm left with x squared minus 7 over 2x minus 5. Half the coefficient of x and square it. So it'd be minus 7 over 2 squared divided by 2. Sorry. All to be squared is equal to minus 7 over 4. All to be squared, which is 49 over 16. Add and subtract that in. So 2 times x squared minus 7 over 2 plus 49 over 16 minus 49 over 16 minus 5. So this is a perfect square. 2 times x squared minus 7 over 2x. So sorry, rewrite this as a perfect square. This is going to be x minus 7 over 4 squared. And minus 49 over 16 minus 5 is equal to minus 129 over 16. Multiplied in, I have 2 times x minus 7 over 4 squared minus 129 over 8. That's my complete the square form there. So therefore, a is going to equal 2, h is going to equal minus 7 over 4, and k is going to equal minus 129 over 8. And I hope I am correct in saying that. Right. Hence, write the minimum point of the function. So the minimum point is just going to be, so remember, PQ is my point here. So P, so A times X minus P all to be squared plus Q. So minus P minus 7 over 4. So minus P is equal to minus 7 over 4. P is going to be equal to 7 over 4. That's my first point. And then Q, or his coordinate I should say, plus Q is equal to minus 129 over 8. So therefore Q is equal to minus 129 over 8. So my minimum point is 7 over 4 and minus 129 over 8. That is my minimum point of this function. And finally, explain why f must have two real roots and write the roots in the form p plus or minus root q. So why it must have two real roots. So what we could do is either we can comment on the discriminant of this, of 2x squared minus 7x minus 10, and say the discriminant is greater than 0. But it's also asking us here to write the roots in the form p plus or minus square root of q. So they want us to write it as something plus or minus square root of something. So what we can just do is we're going to solve now my complete the square form here we got in part 1. And we'll see where it takes us. So 2 times x minus 7 over 4, all to be squared, equals, minus 129 over 8 equals 0. 2 times x minus 7 over 4 squared equals 129 over 8. X minus 7 over 4 squared is going to be equal to 129 all over 16. X minus 7 over 4 is equal to root 129 over 16 plus or minus root 129 over 16. X therefore is going to equal 7 over 4 plus or minus the square root of 129 all over 16. And that's my final answer there. There are my two roots. These are real and distinct roots as the discriminant will be greater than 0, right? So, you can comment on discriminant, or the fact here is like these two roots are real and positive. But if you want to comment on the discriminant would be b squared minus 4ac is greater than 0. So it's going to be minus 7's b, 2 is, so b, a, c. So it'll be minus, always happens, right? Minus 7 minus 4 times 2 times minus 10 greater than or equal to 0. 49 minus 4 times minus 20 is greater than 0. 49 plus 80 is greater than or equal to 0. 129 is greater than or equal to 0. Yes, it is. Therefore, they are real and distinct. Right, and that is completing the square and commenting on them. And I hope this video was some help. And I'll catch you guys later. Bye.